We live in a world hungry for energy. Our lights, our devices, our entire modern lives depend on a steady flow of electricity. Among the many ways we generate this power, nuclear energy stands out as both a beacon of hope and a source of anxiety. Nuclear power plants tap into the immense energy locked within atoms. They utilize a process called nuclear fission, where the nucleus of a heavy atom, usually uranium, is split, releasing tremendous amounts of energy in the form of heat. This heat is then used to generate steam, which drives turbines to produce electricity. Nuclear energy offers a significant advantage. It's a carbon-free source of power. Unlike fossil fuels, it doesn't release greenhouse gases into the atmosphere, making it a potential solution in the fight against climate change. However, this promise comes with a profound caveat: the risk of a nuclear meltdown. The spectre of a nuclear meltdown looms large in the public imagination, conjuring images of widespread devastation and invisible lingering radiation. Understanding the science behind these events and the measures in place to prevent them is crucial as we navigate our energy future. At the heart of every nuclear reactor lies a delicate balance. Nuclear fission, the process that powers these reactors, is a controlled chain reaction. Imagine a cascade of dominoes, each representing an atom. When one domino falls, an atom splits, it triggers the next, and so on, releasing energy with each topple. A meltdown occurs when this controlled reaction spirals out of control. The heat generated becomes excessive, exceeding the reactor's ability to contain it. The reactor core, containing the nuclear fuel, begins to overheat, potentially melting down like wax under a blowtorch. This meltdown can breach the reactor's protective barriers, releasing dangerous radioactive material into the environment. This release can have devastating and long-lasting consequences for human health and the surrounding ecosystem. Understanding the delicate dance between controlled energy release and catastrophic meltdown is essential to appreciating the gravity of nuclear safety. History bears witness to the devastating consequences of nuclear meltdowns. 3 Mile Island, Chernobyl, and Fukushima stand as stark reminders of the potential for disaster when the invisible power of the atom escapes its confines. In 1979, the 3 Mile Island accident in Pennsylvania, USA, sent shockwaves through the nuclear industry. A combination of equipment malfunctions and operator errors led to a partial meltdown, releasing small amounts of radiation. While the impact was relatively contained, it eroded public trust in nuclear power. The 1986 Chernobyl disaster in Ukraine, then part of the Soviet Union, stands as the world's worst nuclear accident. A flawed reactor design and human error resulted in a catastrophic explosion and fire, releasing a massive plume of radioactive material into the atmosphere. The disaster caused widespread contamination, displacing communities and leaving a lasting legacy of health problems. In 2011, the Fukushima Daiichi disaster in Japan, triggered by a massive earthquake and tsunami, highlighted the vulnerability of nuclear plants to natural disasters. The meltdown of 3 reactors led to the release of radioactive material, forcing evacuations and raising concerns about long-term health and environmental impacts. These events serve as grim reminders of the potential consequences of nuclear accidents and the importance of robust safety measures and emergency preparedness.